Assalamu alaikum.
Welcome, salam.
Sorry for the delay. Okay.
That's all right.
So we were discussing the questions regarding um, ionic equations and ionic solutions, something like that. So, and these were pretty much easy. And did you take a look at them? Like, what would be the ionic equation for this, or maybe this?
No,
Okay.
I was
So be real quick. Tell me the ionic equation for this one. Okay. 10b.
where? Oh, ionic equation. Uh,
You can see that they have said that overall balanced precipitation reaction. So you could even like write the only precipitated part. That's also okay.
the precipitate. Um, is that barium? I'm not
Yes,
sure if that's
barium,
barium or not.
barium. Yes, barium. It's barium.
Barium is number 56, and it's metal,
Remembering number
which would be plus
56 is
two.
not important. Yes, remembering
Plus
plus 2 is
two,
important. Yes.
minus two. So barium is plus two, chlorine is minus one, but there's two, so minus two. So ion equation will be plus two, minus two.
What are you saying? Why would you write ionic equation like that? No.
I
Okay,
have no clue.
complete the whole thing and then give me an image. Okay, then I will discuss about it. Okay. Write the whole thing, then I will
I
see.
have no clue.
I mean, write down first, then I will explain. Just try. Like the previous day, what we did. Just follow that thing. Okay. The charge doesn't change. Doesn't change. What you would do here is like chlorine is -1, then how many chlorines are there? Two. So that is why that get
Two.
balanced. Okay. So the starting would be something like this, like Ba2 plus Ba2 plus 2Cl minus. Okay. So I have given you the hint. Now I think you should be able to complete it. Okay. Now write down the next ones as well. And like the thing you said, that oxidation number, if it's less, then I mean it gets multiplied to get a zero, something like that. Yes, it's okay, but we don't write equation like chlorine would be -2. Chlorine doesn't get -2 any, I mean anytime. Okay. And this is also a common confusion that the students have while like studying redox equations at the very beginning stage. Yeah. Give me an image when you're done. Done?
No.
Take 30 seconds. Come on. Okay. Okay, see.
Okay, give up. Yeah.
Um so this is our whole equation. I don't know if you have forgotten or what. First of all, what you are trying to do is like identifying the oxidation numbers. That is great. Okay. So barium's oxidation number is +2, chlorine's -1, sodium's +1, sulfate's -2. Again, barium's +2, sulfate's -2, sodium's +1, and chlorine's -1. Okay, very nice. Okay. Now let us just write down the ions and it should solve that for us. So from the left side, it is Ba2 plus, okay, plus Cl minus, okay, Cl minus, but that will be multiplied by 2 because there are two chloride ions, okay. Then again, Na plus, but how many sodium ions are there? Tell me.
2.
2. So 2 Na plus SO4 2 minus. Okay, so we are done with the left side. We are done with the left side, and you can also give like aqueous signs and solid signs whenever you need. Okay, all right. And then in the right side, what do you have? Ba2 plus SO4 2 minus plus 2Na plus 2 Cl minus. Okay, sodium plus and Cl minus, but they both have been of two, two molecules are there or two ions are there. That is why they have been multiplied with 2. And for better understanding, what did I say? Just put a bracket where you have like distributed in a particular component ions like barium chloride. I have distributed it into Ba2 plus and 2Cl minus. I have put a bracket here. And then sodium sulfate, I have distributed it into ions. Okay, then barium sulfate I distributed into ions and then sodium chloride as well. Okay, so this is our basic ionic equation. All right, and the next thing we could do is like they have said that for the precipitate part, what would be the ionic reaction, ionic equation? Okay, very easy. It would be barium sulfate. So, what is barium sulfate formed of? What are barium sulfate formed of actually? What ions do barium sulfate require?
Ions.
Sorry,
2 plus 2 minus.
uh, can you repeat again? It was very low.
What do you mean by that?
I mean, see barium sulfate. Which ions are here in barium sulfate?
Plus 2 minus 2.
Please name the elements also. You cannot just
Barium plus 2.
yes,
Sulfate minus 2.
sulfate -2. Very good. And that means that whenever you are trying to write the precipitation reaction, just keep the barium +2 and sulfate 2 minus and write it like this: Ba2 plus SO4 2 minus, then we will get barium sulfate. So this is the shorter part. Okay. Okay. But tell me what went wrong, because we discussed a long time about this. Did you not understand yesterday or did you forget? Which one?
I think I had a mind blank.
Okay, so after completing this, you have to show me one then, okay? All right, so show me this 9B, okay? See, redox equations are a kind of ionic equations as well, right? Because in case of like forming any redox reaction, you would see that there is a what can I say, donation or acceptance of electrons. Okay, so you have to understand the ionic equations pretty well. Otherwise, you might find difficulty in understanding redox reactions as well. Okay. Okay, tell me when you're done. Consider nitrate as a composite ion. Okay. What is the charge of nitrate ion? Do you remember?
A nitrate iron. Nitrate iron. Yeah,
Yes.
-1.
-1, right? Okay. Go ahead.
I'm done.
Did you were you writing these?
No. I finished writing that.
Okay.
So I'm done.
Okay. So I'll write down the answer. If you find any discrepancies, please let me know. Okay. So nitric acid, okay, or HNO3. So here hydrogen is +1, nitrate is -1. Sodium hydroxide, sodium is +1, hydroxyl ion is -1. Then sodium +1, nitrate ion -1, hydrogen +1, oxygen -2. Okay, now let's see what can we do. So from the left side, H plus NO3 minus, okay, then plus Na plus OH minus, and we will get Na plus NO3 minus plus 2H plus, because there are two hydrogen ions, plus O2 minus. Okay, so is it the same that you got?
Yes.
Okay, that's good. That's good. All right, and you could form brackets here. All right. Okay, now now. Okay, actually, here's a thing. Here, other than writing 2H plus, it's better if we write this. Okay, fine. Just a little correction. Okay, how is water formed? How is water formed? Water has two ions, right? Two ions. One ion is hydrogen ion and another one is hydroxyl ion. Is it correct?
Yes.
So although it's seeming like that there are two hydrogens and one oxygen, it's better to write it like this. It's better to write it like H plus OH minus. Okay. All right.
Oh, okay.
Because here, I mean, rather than thinking that oxygen ion and hydrogen ion are working, it's like hydrogen ion and hydroxyl ion are working. Okay. So that is more appropriate.
Done.
All right, so now let's get to redox reactions again. Please revise the things of ionic solutions as well. Okay. Okay, tell me what is oil rig? Why did we remember the mnemonic code oil rig? Tell me.
No idea.
You can't say no idea. We just read it yesterday.
Oil rigs.
OILRIG. What does it mean?
Um,
What is the full form of this? Ulrich.
No idea. I'm sorry.
Okay, if you don't understand things, you have to ask questions then.
Okay.
Oxidation is lessening of electrons. Remember this sentence I uttered yesterday. Or do you not remember that? Oxidation is
No.
lessening of electrons. Actually, you were tired yesterday, so yes, I think that could be it. Oxidation is lessening of electrons. See, oxidation. O. I for is, L for lessening. Okay. And reduction is gaining. Or you could say gain of electrons. Okay. Gain of electrons. All right. So reduction R is, I is, and G. Okay. So what I mean by that is whenever you will see an oxidation process, there has to be a reduction of, I mean, electrons will be lessened, and in case of a reduction procedure, electrons will be gained. Okay. Again, if I give you a very simple example, say for instance, sodium donates electron or sodium lessens electron, that means it is, tell me, which procedure is it?
Ionize.
I mean, not,
Reducing.
okay, why is it
Reducing.
reducing?
Because it's taking away an electron.
Yes, I mean, sodium is a reducing agent. Okay, that is
A
correct.
reducing
Sodium is a
agent.
reducing agent, but what is the process? What is the process name? Process could be oxidation or reduction. A particular element or a
Reduction.
particular ion could
Oh
be,
no. Oxidation.
right. So it's you are bound to get confused. That is why I'm saying it again and again. Okay. So a particular element or a particular ion could be a reducing agent or an oxidizing agent. Listen very carefully. An ion or element, or yes, composite ions are also ion, could be an oxidizing or reducing agent. Okay, see the term agent. Okay, so in that way, say agents are human beings, that is why like agents could be like ion or element, you could memorize it like that. So agent, but the whole reaction or process will be termed oxidation or reduction process. Oxidation or reduction process. Good. So keep that in mind, and you could like write something like this, which our teacher used to do at the very beginning of understanding redox reactions. That is, form a simple table like this. So this is the table. So what he did was, in case of reducing agents, he would write reducing agent at the top, reducing agent. Okay. And at the bottom, he would write oxidation. Again, in another table, he would write oxidating agent and reduction. Okay. So that the students don't get confused with the thing. Okay.
Got it.
All right, good. All right. So now say what is this? What will be this process? Tell me.
That would be a what? Oh, that would be a reduction process.
Reduction process. Excellent. Okay, reduction process. It's a reduction process because there is a gain of electron. Okay, there is a gain of electron. Now, would we find a reducing agent here or oxidating agent here?
No.
Can you hear me?
Yes.
Okay. So what I was saying is, would you find an oxidating agent here or a reducing agent?
I don't think so.
What do you not think so? I don't get your point.
Like, no.
What I am asking is that obviously if there is a reduction procedure, there has to be an agent, right? Other than that, it won't work. So do you think that, I mean, there is an oxidating agent or is there a reducing agent?
Mm,
Did
reducing
you
agent.
did you draw the table? I show you. I showed you two
Oh yeah, the
tables.
table.
Yes, there were two tables. Remember,
Yes.
first one was oxidating agent, and then underneath what was it? What was here?
Reduction.
Reduction. So in case of reduction, which agent will we find?
Oxidating.
Oxidating agent, right? And which is the oxidating agent here?
Um, Na plus.
Yes, excellent. So Na plus is the oxidating agent here. So oxidating agents, I mean, receive electrons, right? Okay, and the
Yes.
process in which oxidation, the process in which the gain of electrons can be seen, that is our reduction process. Okay, and process in which electrons are being lessened, that will be our oxidation process. Okay, so remember
Okay.
the oil-rig formula all the time, because otherwise you will get really confused. Okay, these two terms are really confusing, right? You are bound to think every now and then that oxidation is reduction and reduction and oxidation. Okay, so that might be a problem. Okay, all right. So tell me, are you clear with the terms oxidating agent, reducing agent, oxidation, reduction?
Um, okay, so the
Yeah.
oxidating agent is the reduction.
No,
Um,
oxidating agent takes part in reduction. Okay.
yeah, it takes part.
Yes.
So does that mean for the other way around?
Yes.
Okay.
What do you mean by the other way around? I mean,
So
like,
the reducing agent, it is takes part in the oxidation.
yes, exactly. Yes. That is how it goes. Okay, all right. And in the reduction process, you will see that electron is being gained, and in the oxidation process, you will see that electron is being lessened. Okay, all right. So that is why I'm saying, I mean, where electron is being lessened and where electron is being gained, that is the most important part. Okay, all right. So oxidating agents will gain electrons, and in the process of reduction, electrons will be gained. And similarly, in case of oxidation, electrons will be lessened and reducing agents will donate electrons. All right.
Yes,
Okay. I hope it's clearer than yesterday now. I hope so.
it's getting, yeah.
All right. I hope you have taken notes of these.
Yep.
Okay. So now they have showed you some examples. Okay. Let me just get with the example of that. Okay. So copper sulfate plus zinc, a very easy and common oxidation reduction reaction. We'll get zinc sulfate plus copper. Okay. Now you will go ahead and tell me what are the oxidation numbers of which particular part. Okay. Firstly, write down the equation or reaction, then tell me. Like that zinc's oxidation number is +7 or sulfate's oxidation number is +99, like that. Okay, let's start from the left.
Just one second. Cu. Cu plus 2
Cu plus 2 next.
plus NO. Sorry. SL4 minus 2
Okay, next.
or 2 minus plus
Sorry.
zinc.
Yes,
Sorry.
zinc.
2 plus.
Why zinc 2 plus?
I have no clue. What is zinc? Zinc's on the
Zinc
right
is
side.
a free element here, right? What do we do in case of free elements?
0.
Right. Next.
Zinc 0.
Where zinc 0? Yes, I've write zinc 0 then.
Oh, zinc 2 plus.
Zinc 2 plus. Here it's not a free element, it is connected with sulfate ion, right? But here it was a free element, it was alone by itself. Okay, all right. The next.
Plus Cu 0.
Cu 0, and you have missed one thing.
Oh, SO4 2 minus.
So 2 minus. Okay, now let us try to identify what will be our reduction part and what will be our oxidation part. Okay, so see, copper was +2 here and 0 here. That means copper has gained electron. In case of gaining electron, what do we call this process?
Reduction.
Reduction, reg, right? Reduction is gain.
Yes.
Okay. All right, so this will be our red. And now let's see what will be our oxidation. Tell me. You will tell me what will be our oxidation part.
Zinc.
Yes, zinc. Zinc 0 to +2. Okay.
Yes.
And now tell me one thing. What is sulfate doing here then? What is the role of sulfate here in terms of like ions? What do we call them?
It is picky. Okay,
Sorry?
it just takes
No,
it
it doesn't
is
take or it does not receive. It just
it's the
like
agent.
gets attached with other ions. Okay. And it does not
Yes.
take any ion and it does not receive any ion. Okay. These sorts of ions who do not change any oxidation number in a particular reaction, we call them spectator ions. Spectator ions, because they just spectate, they don't do anything. Okay, spectator ions. Okay, understand? They won't change their oxidation number, they won't change their oxidation number. Okay, all right.
Okay.
Now let's try to form the reactions. Okay, so firstly, if we see the reduction reaction, so we have copper 2 plus. Okay, so write down copper 2 plus, and then it receives 2 electrons. Okay, and then forms copper. I hope it's not that difficult, right?
No.
Okay, now just write down half mm, half half reduction, sorry, reduction.
How is it half reduction?
I explained it to you. Redox reaction means reduction and oxidation. Okay, so in any sort of reaction, half of it is done via reduction and half of it is done by oxidation. That is why whenever we write the reduction reaction and oxidation reaction, we should write half reduction and half oxidation. Okay, all right,
Okay.
because they are half of the whole process of redox reaction. Okay, understand my point?
Yes.
Okay, good. Now zinc has donated 2 electrons to form zinc 2 plus. So this is the easiest way to write down any oxidation or reduction reaction. Okay, this is the easiest way. I don't know what your book has showed you or how they have explained, but I would say this is the easiest way. Okay, firstly identify the particular element or the composite ion on the left side, and then uh, figure out how many electrons are being gained or how many electrons are being reduced, and then with the positive or negative sign show that amount of electrons, and in the right side write down the ion or write down the free element. Okay, that is how you have to go on with the oxidation reduction reactions. It will be a little difficult at the very beginning, but as time passes by you will see that it gets really easy. Okay,
Okay.
tell me when you're done.
I'm done.
Okay, let's see. Okay, so they have showed, see, they have showed zinc first, and then you might think, okay, why did the electrons go in the right side? There a confusion arises. But the plus 2e minus, if you take it to the left side, what will it become? Tell me.
Uh, 2 plus.
No, no, I
Oh,
am
sorry,
saying,
zinc.
uh,
Yeah,
no, 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 you don't complicate it. Okay, see, this is plus 2e minus. If you bring it to the left side, what will happen? Basic
minus.
properties of equations, right? Minus 2e minus. Okay, so that is what we wrote down previously, but that is easier to understand. Okay, like zinc minus 2e minus, that means, okay, that means this is a oxidation process because electrons are being lessened. But if you write it in this way, it becomes a little difficult for you to understand. Okay, right? But if you think that this is easier for you, go ahead with it. You will get full marks for both the terms. But I would suggest that keep the gain of electron or lessening of electron in the left side all the time. Okay, understand my point? Are you understanding my point, what I say? Hello, I cannot hear you. Can you hear me?
Hello. Yes, I can hear you.
All right, so what I was saying is that do you get my point, what I was trying to say?
Yes.
Okay, good. All right, so okay, we will continue. Let's give well another link. 1 second.